So if you recall, to find the limit, to find the derivative, so we're trying to find p prime of r. We're going to take the limit as h approaches 0 of p of r plus h. So I want you to think about this. Typically we see f of x plus h because this would have been an f of x function. Since we have a p of r function, this now becomes p of r plus h minus p of r all over h. So the four-step method would have you calculate this first, then the entire numerator, then divide it by h, and then take the limit of that. I'm going to head and do the four-step right here in the solution. So p of r plus h, what does that mean? Remember, p of something basically means take that something, whatever it is, put it in your original function in place of the original input value, which becomes 1 plus r plus h. So I want you to think about this r plus h is replacing the r. That quantity is squared minus, and the original function is what we have here, 1 plus r quantity squared all over h. So what we have now, we're going to expand this. And remember, we don't use the f word because, as you can see in this particular case, we have three quantities. So we have 1 plus r plus h times 1 plus r plus h. So if I just do the work over here, you'll notice we have the first term times that whole quantity. So 1 times that whole second parentheses, plus, then we have the second term times that whole parentheses. So r times 1 plus r plus h, plus, and then the third term, h times 1 plus r plus h. So when we expand this, we end up with 1 plus r plus h plus r plus r squared plus rh plus h plus rh plus h squared. Now I'm going to simplify all this when I bring it over here. So that whole quantity squared becomes 1 plus, we've got 2 r's, 1 plus 2r plus, so there's the 1 gone. Let's see if we can see this a little clearer. The 2 r's are gone. We have 2 h's. So 2h. Then we have 2rh. We have an r squared. And the last term h squared. Now remember, this is only this first piece. we still have to calculate or expand the second parenthesis, which will become 1 plus 2r plus r squared, but we're going to multiply it by that negative, so 1 minus 2r minus r squared. Hopefully I didn't lose you guys on that. If I expand this, I end up with 1 plus 2r plus r squared, but I've got to multiply every term by the negative. So now we're going to go through and do what we did earlier. Simplify, so 1 minus 1, 2r minus 2r, r squared minus r squared, which leaves us with the limit as h approaches 0 of 2h plus 2rh plus h squared all over h. Now what do you notice at this point? What is common to every term in the numerator? That's right, an h. So what we want to do is factor out an h. Notice on each line I'm still writing limit as h approaches 0. So we're going to factor out an h, and we're left with 2 plus 2r plus h all over h. Now at this point we can say, since h isn't equal to 0, but it's getting very, very small. In fact, it's so small it can disappear, and we have it common both here and here, so that's why we can cancel it out. Simplify it, which leaves us with 2 plus 2r plus h. Now at this point it equals 2 plus 2r plus h. However, we did say that h gets really, really close. It approaches 0. So if this piece gets really, really small, our final answer simply becomes 2 plus 2r. And that's the final answer for number 10. The last thing we have to do, remember the question said, determine the limit or the derivative when r equals 0.07. So at this point we can say p prime of 0.07 is equivalent to 2 plus 2 times 0.07. And that ends up as 2.14. You can use a calculator for that. So the final answer, the derivative of this function when r equals 0.07 using our limit definition, which at this point is what we're using to find the limit, the derivative, is 2.14. In other words, the instantaneous rate of change at 0.07 of this function is 2.14. The slope of the line at 0.07 is 2.14.